everyone, it's Alyssa and welcome to You Can Learn Math. Today we're going to talk about how to calculate compound interest or how to solve compound interest problems. Now these are problems that are interest that is being compounded annually, once a year. It is the introduction point for the sort of compound interest problems. I'm going to make some videos very shortly, they'll be up in a week or two, that will cover compound interest when it's being compounded multiple times a year, like every week, every quarter, every month. Also, for those that are being compounded continuously, different problems. I will make videos on those separately. Okay, so for today, we're going to talk about the formula itself. We're going to talk about why that formula is the way it is. Then I'm going to do 4 different problems. I know it's going to be a long one. 4 different problems solving for these 4 different variables because, believe it or not, there's different techniques involved. The first one is going to be when you're solving for the final amount. The second one is going to be when you're solving for the principal, what you started with. Third one is when you're solving for the rate. And the fourth one is when you're solving for the time. Yeah, especially those last 2, the method gets different. So I'm going to put markers below, so if you have one of those, if you just have a question about one of those specifically, you can just jump straight to that point because I know it's gonna be long. Right, so part 1. What is our formula? This is our formula. I've seen this written a couple different ways, but this is our main basic compounded one time a year, compounded annually formula. What do these stand for? This A stands for the final amount, the amount you have in your bank account when this is said and done. P here is for principal. This means the beginning amount, what you started with, your beginning amount of money. This one right here is the rate. This is the interest rate. And T is for time, and this in this case, and this variable in this case is how many years. Okay, so where did this come from? Why does this work? So I'm going to put it up over here to the side for just a minute. Let's imagine that someone has $500 and you had this magical bank account that pays you 5%. And you say, I want to figure out how much money I'm going to make every year. 5% compounded annually. Okay. So, all right, the first year I would multiply by 5%, but I'm going to change that into a decimal. And that means like, I'm going to make $25. So at the end of the first year, I have 500 plus 25 or $525. Well, is there a way that I could combine those 2 steps, make it easier to figure out how much I'm going to make every single year? Well, there is. 500 is the same as 100% of what you started with, and 25 is the same as 5% of what you started with. So 525 is the same as 105% of what you started with. So I could say, well, I multiply what I started with by 105%. Or I can rewrite 105% as 1.05. And I would get the same answer. And then I say, okay, well, what happens the second year? I take that 525 and I multiply it by 1.05. And then I just keep doing that. Times 105, times 1.05, times 1.05 every single year. So let's say, if I wrote this in series, like 3 years, I would just keep, if I was doing it on my calculator, like how much would I have after 5 years? I would just keep pressing enter. I would just keep multiplying by 1.05. And if I did that and I get my answer down here, let's actually do it. I'm going to take my calculator. I'm going to say 500 times 1.05. 1, 2, 3, 4, 5. And I get $638.14. Well, what happened? This is after 5 years. I had what I started with. I multiplied by 1.05. I did that 5 times and I got my answer. Let's look how this ties into here. What I did was I took the beginning, or my principal, I multiplied it by 1.05, which is the same as 1 plus 5%. And then I multiplied 1.05 5 times 1.05 times 1.05. So I did it to the power of 5. And 5 was the number of years. And what did I get? I got $638.14. Means I got my final amount. So that's where this all comes from. Now let's do some problems that, where we apply this. Yay! So here is our first problem. I'm going to leave these little notes here. Just kind of set this off to the side so we can have it as a reference as we go. So here's our first problem. A person puts $500 into a savings account, and this is an amazing savings account that earns them 4% interest. After 6 years, how much money is in the account? Okay, so let's put each of these numbers into this formula piece by piece and let's see what's missing. Okay, so here is my formula. What am I given? Well, I'm told how much money was put into the account. That's $500. So that is my principal, $500. I'm told that this makes, again, what savings account does this? 4% interest. That is my rate, 0.04. T is our number of years. Are we given that? Yes, we are. We're told it's 6 years. So I'm going to put in 6. And the question is, what is the final amount? Hey, that's our only variable left, A. Now this is just a job for our calculator. I can, if you are questioning how to put this into a calculator, I'm going to write this all down here separately. First thing you want to do is this right here, 1 plus 0.04, which gets you 1.04. Then on your calculator, you're going to put it to the power of 6. That gives you 1.265, and it keeps on going. Without touching anything, type in times 500 equals, and you will get your final answer. And that answer is $632, and I'm rounding to the nearest hundredth because it's dollars and cents, 66 cents. That's our answer. So that's pretty straightforward. We're just typing things in a calculator. Just be careful that you do it in the right order. Okay, so there is our first one where we're trying to figure out how much money after so many years. Then the second variety that I guarantee you they're going to throw at you. They could throw all these at you eventually. The next one is going to be, go away. All right. Let's say a certain person put money in an account that pays 5% compounded annually. After 13 years, they have $22,627.79 in their account. How much did they start out with? Or what was the beginning amount? Right, well, let's look at our formula and let's see what's missing. We are told 5%. That would be our rate, which we are going to write as 0.05. We are told 13 years. That's our time, 13. And we're told that they ended with, wish that was me, they ended with $22,627.79. That is their final amount. So that goes over here. So this time, when they say, what did they begin with? They're asking for the principal. Right, so how do we do this one? This one's very similar to the first one. It's pretty straightforward. Not any crazy stuff. We do need a calculator though. We're going to start over here. 1 plus 0.05 is 1.05. And we're going to use our calculator to put that to the power of 13. So again, it's going to be our little x to the power of y. So we type in 1.05, x to the power of y, and then 13. And we get this very long number, 1.8856, and it keeps on going. And p times all that is equal to 22,627.79. Now we're going to divide 22,627.79 by this long number. Now, the longer you can put into your calculator, the closer you're going to be to the correct answer. If you want to get fancy, you can, if you know how to use parentheses and things in your calculator, you can do it so it does this all at once, where it divides this by 1.05 to the power of 13. For most math problems, most tests, that's not strictly necessary. You can do some rounding, but the less rounding you do and the longer this number is, the better. So I'm going to divide by 1.885649 on both sides. I'm keeping it long because I want to be very close to the right answer. And I get that my principal is, rounded to the nearest penny, $12,000 is my principal. Someone puts $1,000 in an account, and 8 years later, they have $1,199.51, and this compounds annually. What is the rate? So let's put in our numbers and see what we need to do. What do we have? Well, we have $1,000. What is that? That's the principal. That's what we start out with. So I plug that in here. Next, I have over here 8 years. The money's there for 8 years. What is that? That's our time. So I'm going to put that 8 right there. Next number we're given is $1,199.51. And we're told that's the amount in the account after this. So go, okay, well, that is our final amount. $1,199.51. Okay, so for this one, different process. We're solving for a different variable. It's going to look a little different. We have to do a little algebra. We can't just type it in the calculator. Okay, first thing we're going to do, I want to get rid of this 1,000. I'm trying to get r by itself, so I'm working backwards. The 1,000's got to go first. So I'm going to divide this side by 1,000 and this side by 1,000. When I divide that left side by 1,000, I get 1.19951. On the right, I get 1 plus r to the 8th. So this is definitely a calculator portion. Think about this. If I said, in a similar problem, like if I told you 9 equals x squared, to solve this, you undo the square by taking the square root. Okay, in a similar manner, this is a power of 8 to the power of 8. We need to undo that. We undo that by taking the 8th root. That seems a little crazy, but that is the way to do it. We take the 8th root. So this is definitely a thing for your calculator. Many calculators, like I have an iPhone, on the standard little calculator that comes with your iPhone, if you turn your calculator sideways, turn your phone sideways, you get more buttons to the left. One of those buttons looks like this. So for this one, X is whatever number you type in first. So you're going to type in this number, 1.19951. Then you're going to hit this button, Then you type 8 because that's your second number, your y, and then equals, and you will get your answer. Okay? So your answer is going to be, for the 8th root of this, 1.022, and you get 999, okay, equals 1 plus r. So finally, to solve for r, we are going to subtract 1. Come on, go up. Subtract 1 from both sides, and we get r equals 0.022999. So we can definitely round this, and it's going to be 0.023 or 2.3%. So when you're solving for that rate, you're going to be using roots. So our final one is where things get the trickiest. So we've had some ones that were just, some more basic calculators and a little more advanced calculator usage. This one takes some doing. So our final question here is they're going to tell us that someone put $2,200 in an account and it's earning 3.7%. And after a certain amount of time, they had $4,892.78. How long was that? How many years had passed? All right, well, let's take our formula and let's plug everything in. Let's find out what we know. Well, first thing we're told, they started with $2,200 in the account. So that's our beginning amount, our principal. It earns 3.7%. That's our rate, which we write as 0.037. To the power of t, we don't know the t. T is the unknown, how many years. And lastly, we're told this amount, I accidentally erased, highlight, not erase, that this is the final amount. So we're going to write that over here as the final amount. And they want us to solve for that t, or time. Okay, well, what should we do first? Me, like looking at it algebraically, I'm going to say, let's get rid of this 2,200. Let's divide both sides by 2,200. Let's do that first. Okay, so let's see what that gives us. So if I divide 4,892.78 divided by 2,200, that gives me 2.22399. And you can safely round that to 4. That's so close to 4. 0.224. Okay, so it equals 1 plus 0.037 to the power of t. I'm going to go ahead and combine those two to just be 1.037 to the power of t. And you go, oh, well, I can't take a root because I can't, like before when we had like, oh, we want to solve for this. So we take I can't take the t root. I don't know what t is. So what do? Oh, this is where logs come in. If you groaned or cringed when I said that, I feel you. Believe me. If you would like a refresher on logs, links are below. They're not my favorite either. I say this because I feel confident they're probably not your favorite. They're very few people's favorite. As a very quick refresher, if I had something like 3 squared equals 9, I could write that as log base 3 of 9 equals 2. It always goes 3 to the power of 2 equals 9. That's how they are equivalent. These two things are the same. So we are going to rewrite this as a log, and that will let us use our calculator to solve this. So remember, this is our base, like here. So log base 1.037, and then to the power of, so power goes here, and then What it equals in the exponent goes here. So here's what it equals in the exponent. It goes here. Now this I can solve. You have to have the special function in your calculator. It is usually written as log base. And then it goes like this. And you put here, you put the base. You're going to enter it as 1.037, comma 2.224. And when you enter that and hit equals in your calculator, the result is 22.000. So the answer is 22 years. Okay, so that's it for compounding annually. As I said, if you're looking for compounding several times in the year, compounding continuously, those videos are coming. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.